Okay, 5.2 basically is the Cpctc theorem, and we're going to go over that and what it means in a second. But the first thing that we are going to deal with is identifying corresponding parts of triangles, and we're going to deal with congruent triangles. So moving forward, the biggest thing is we want to do is have congruent triangles, which means the triangles are the same shape and size. Okay, and so what we need to be able to do before I discuss what that is we need to look at different triangles and figure out the corresponding parts. And corresponding, we had that word already. Let's see if I can actually draw this so it sort of looks congruent. Okay, they're going to mark this stuff up. Here it is. And so you're going to have to get used to the marks. So I'm going to call this one A, B, C. I'm going to call this one X, Y, Z. All right, they're going to mark it up for you so you have things. So A is going to like this. This is going to be like this. And this is like this. Okay, so 1 would correspond to 1, and they would also be congruent. 3 would correspond to 3. Does everybody see the difference in that? If you can't see this great, we're on 216, and we're right there at the top underneath where it says identifying using corresponding parts, and they have that maybe more clear. Okay, I'm going to do the other line in purple, even though it will always be in red, just so you can see the difference. So sides work the same way. Where the one, let's see if I can make it a little more focused. Okay, where the 1 is congruent to the 1, and the 2 is congruent to the 2, and the 3 is congruent to the 3. Okay, what this means in this case. And then I'm gonna write down the corresponding parts, and then we're going to make a statement out of it. So this means that angle A is congruent to angle Z. Angle B is congruent to angle Y. Angle C is congruent to angle X. Also, segment AB is going to be congruent to segment YZ. Segment AC, what's that congruent to? ZX. ZX is better. And what is left? BC? Segment BC is going to be congruent to? Yep. Yours is better, YX. And we barely can see that. And so we don't want to write this every single time, do we? So there's got to be something called a congruency statement. And I'll show you how to do that. I'm going to put the right ending on congruency. Okay. It really is that. All right, congruency statement. All right, so this is how I'm going to do it. I'm going to abbreviate this. I'm going to draw the triangle symbol. This means I'm talking about a triangle. I'm going to say this is triangle ABC. That triangle ABC is congruent, and this is important, the order of the next one. First order, usually we do alphabetically. You don't have to, but usually you do. Second one is, what angle does A go with? So triangle Z, what angle does B go with? What angle does C go with? Okay? And so with this, we can do all this information. So AB, segment AB goes with segment ZY or YZ. Doesn't matter, does it? Segment BC goes with. Okay, so basically this is the same thing as this. Does that make sense? This takes less time to write. Okay, so we're going to use this in several chapters where we will get a congruency statement and it will mean certain things. So if they give us a statement, it does mean that these triangles are congruent, and it means all the parts are congruent, and that brings me to the Cpctc theorem. So what this stands for, this theorem right here, I'm going to write it again. Congruent. See, I messed it up already. Corresponding parts of congruent, now we get to use congruent, triangles are congruent. So now you know why they want to write this on the internet as opposed to write all this every time. Okay, so basically how this works is C, P, C, T, C. So this theorem basically says that if we have two congruent triangles, then all the parts are also congruent. Okay, I wish they wrote that in your book, but they don't really write that in this book for some reason. But in the internet, it's there. Okay. I also want you to point out some properties. We don't have to rewrite them. But I do need you to know them because we're going to potentially use them. And so you might want to write theorem 5.3 in your book. It says reflexive, symmetric, and transitive. This means we can use those properties we've already learned with triangles. So someone did the proof that says it works, and a lot of them just make sense. You know, like reflexive. Triangle ABC is congruent to triangle ABC. That makes sense. Symmetric, that just switches the order, right? And transitive, we might have to use transitive. You know, if triangle 1 is equal to triangle 2 and triangle 2 is equal to triangle 3, that means triangle 1 is equal to triangle 3. Okay, and I don't need to leave this on the board because it's in your book on page, I bet you can guess which page it's on. All right, this is basically it, except for we have one more theorem. It's called the third angle theorem. And so we're going to write that down. That's on page 218, so get that written down. So that's theorem 5.4. And a lot of times we're writing these theorems down because you're going to need them on your homework. And I usually abbreviate third angle like that. You might not be able to see what I'm doing. So I will fix it in a second, because I'm all zoomed in. So I need to zoom out. Okay, so we do need to write down the third angle theorem. That's how I abbreviate it. And it basically states that if two angles in a triangle are congruent, then the third is congruent, basically. And we're gonna get the busy work out of the way today, and then do the harder stuff tomorrow, so we can move on with our lives.